Hello and a warm welcome to our special conversations in the run-up to the Independence Day, where we are talking to the heads of various institutes and ministries. In today's episode, we have with us a very special person, Secretary to the Government of India in the Ministry of Earth Sciences. I welcome Mr. Madhavan Nair Rajeevan. I welcome you on the program.
Thank you.
Mr. Nair, Ministry of Earth Sciences is a fairly new ministry which was formed in 2006. So from 2006 to 2020, if you look at the journey, how has it been? How fulfilling has it been?
It's a really significant achievements we have done for last 14 years. In 2006, at that time there was a Department of Ocean Development, which were responsible for only for ocean. And India Meteorology Department, IIT in Pune, that's one center in Noida. These are all related to weather and climate services. It was part of DST, Department of Science and Technology. So in 2006, government took a decision. If we talk about Earth system science, it comprises of atmosphere, ocean, hydrosphere. So if you really want to do a service to the nation, you should think of holistically all the aspects of Earth system. So atmosphere part of DST and Department of Ocean Development separate in ministry doesn't really go well. So they decided to merge it together, and it was a very good decision. And 2006, all the concerned institutions and departments came together, and Ministry of Earth Science was formed. Since then, we achieved made tremendous achievements.
But if you look at the various programs which have been incorporated as what you call the integrated programs, what are those major programs which are the real highlights of the ministry?
See, we run 4 major programs in the ministry. One is on weather and climate services. Second is on ocean services, which include development of ocean technology. Third is on earthquake, that means seismology and geoscience. And fourth is polar science. And so this is it will cover everything of Earth system science. Then the fifth component, we also do a small R&D program in which we support universities and institutions for the R&D work. So these are the 5 major programs we do.
This particular R&D work which you are saying, where you collaborate with universities, so you encourage students to come and study, and how is it like?
Actually, basically it is we will be funding their research projects. Okay. They will be submitting proposals, we will be funding them, and also there is a training program for them, and they can come and work with our institutions and do their PhD, etc.
Not many people know about the exact work which is really done by the Ministry of Earth Sciences, and it's a fairly new ministry, as we discussed. Yeah. Various programs which have been amalgamated and put together. So for a common man to understand that what exactly is the ministry doing, and how does it really translate in terms of jobs, maybe in terms of what it is giving out to the students, how would you really define that?
Well, Earth system science basically it touches our human day-to-day life. For example, weather. When you go out, we want to know what is the weather today. It's raining, or it will be hot, it will be cold, and also ocean has a huge wealth. Ocean resources we are not tapped really, and we are not really gone out and discovered what is there inside the ocean. And so ocean gives you a lot of energy, minerals, and non-living resources, living resources. It's a huge wealth actually, ocean. And as I told, weather and climate services also touches the human being. And for example, it can help farmers, it can help, for example, forecast for fishermen, it helps fishermen going out, they can be useful. And any application, any general application for general weather forecasts are very useful. And also the most important thing is disaster management,
right.
Saving people from disaster, natural disaster. For example, tropical cyclone. This year we had 2 cyclones, very huge cyclone, one in Umfan, which we gone to West Bengal, another one in Maharashtra, Nisarga. Both we could give a very exact forecast, very accurate forecast, almost 4 to 5 days in advance, which the government took use of it, and they could really help people, and they could save people, thousands of people.
But when you talk about accurate warning systems being in place, and which is why it has helped so many people, whether it was in the cyclone hit areas or whether it was elsewhere, how is this really possible? Does a common man understand that do we have some special kind of computers which are doing this, or do you really have special equipments in place which are there to ensure all this?
Weather prediction science of weather prediction is very complex and highly advanced science. People think that no, they look at the sky and give some forecast. They have small instruments here and there and they predict. It's not so. It's a highly advanced, very complex science which we are now perfecting. We are not. I am not saying that we are perfected, but we are perfecting. Especially last 10-15 years, especially after this Earth Science Ministry has formed, the improvement, significant achievements which we made in weather science, weather forecast is tremendous. Mainly because we could develop, adapt more mathematical models. We use mathematical model for prediction.
Okay.
It's a global model. There are some regional models, and what we use the present weather prediction models are the state-of-the-art models, and which can be compared to any weather prediction officers in any other country like US or UK. And to run this model, and we need observations. So we have huge observations. It's observational network in India, and thanks to a UN agreement, all the countries who take weather observation should really exchange the data.
Right.
So our data goes to Pakistan, Pakistan data comes to us, our data goes to US, US data comes to us. It's all real time. It's all real time. We all take observations fixed time, morning 5:30, 8:30, 11:30, and these observations are exchanged throughout the. So we need observations, we need models. So we have best of best models, we have best of best observations, and we also have a lot of satellites. Not only our Indian satellite like INSAT, we have satellites of other countries, including Europe, US, Japan, China. All they have satellites.
So it's almost like a technological collaboration.
It's a technological collaboration because atmosphere doesn't have boundaries. Weather cannot understand. I am giving rain in Pakistan or India. It doesn't understand the boundaries. So we should not have boundaries in weather forecast. So we have a lot of good collaboration, and that we are making use of it. So then to run this model, it's a highly complex mathematical model. To run this, we need huge computers. I'll tell you why we did not advance about 15 years back, because we did not have money to buy computers. Frankly speaking, I should admit that. So since this ministry has come, now especially last 5-6 years, we have pumped a lot of money to buy biggest computers. Now we have a computer of the size of 10 petaflop we call. With the speed, how the computer speed is. It's cost about 500 crore or so. It is the best computer in this country and one of the best in the whole world. If you consider only the weather prediction officers,
right.
Only America, UK and Japan have better computing facility than us.
And then comes
India. We are the fourth place in terms of computing power.
Okay.
Mainly because this computing power and because we have good models and we have good observation, we are able to now make good predictions. But weather forecasts can go wrong. It's not a 100% correct forecast we cannot make. So sometimes we go for wrong. But if you see the performance last 10 years, we have been improving.
Most of the weather predictions which I have seen, like you're saying, in the last 10 years, of course, have been very precise, quite accurate. If not 100%, then up to at least 98%, we've seen that the precision is there. But what are the challenges which you really see in the coming years as far as weather warning systems are concerned?
Yeah, so
which are the areas where the country needs to work upon?
Yeah, so one is improving forecast for cyclones. We are almost perfected. That's what my feeling. But still there are some issues. But prediction of heavy rainfall for some flash floods is one of the gray areas where we need to really concentrate. And heat waves also we do extremely well. And so some specific gray areas we have identified. So prediction of natural disasters, extreme weather events, that's the main concern for us. For that we need to really improve these models, and also people want now forecasts at a very high resolution. People want that Delhi, not only in Delhi, if you say Delhi weather, no, people won't like it. They want what will be weather at Arkepuram, what will be the weather at Chandni Chowk, that kind of information, 1 kilometer size or 500 meter size. So that's a huge challenge. Similarly, we give, as I told that we give a lot of weather forecast services for the farmers. We reach up to almost 5 crore farmers every day. Twice in a week. And so now we are expanding the network. Now farmers want forecasts at their farm. It may be of a very small size. So at present we are giving at district level. Now we are entering into a block level. So we are giving forecast block.
And gradually at the
so block, then people they will expect Panchayat level, then ultimately farm level. They want a forecast at farm level. It will be too difficult for us, but we are attempting. At least from block level now we have started doing it. So finally we may have to give it at least panchayat level.
That's a significant breakthrough. What you're saying, that at the farm level it will be possible to predict the weather. Of course, it's good news for the farmers, and they have lots to benefit from. But let's take a break at this point of time. When we return, we continue this conversation with Mr. Madhavan Nair Rajeevan on the ocean science and seismology as well. Stay with us.
India Science is an internet-based science TV channel initiated by the Department of Science and Technology, Government of India, implemented and managed by Vigyan Prasar. India Science on the URL www.indiascience.in is a bilingual channel with content in Hindi and English. It can be accessed on any internet-enabled device. This video platform is dedicated to science and technology knowledge dissemination with a strong commitment to spreading scientific awareness, especially with Indian perspectives, ethos and cultural context. The India Science mobile app can be downloaded from the Google Play Store and Apple Store.
Welcome back after the break, and we are in conversation with the Secretary of the Government of India to the Ministry of Earth Sciences, Mr. Madhavan Nair Rajeevan. He is also Chairman of ESSO and also the Chairman of the Earth Commission. Welcome back again, Mr. Rajeevan. To continue with our conversation on ocean science, we spoke about how weather warning systems in the country have improved, but a lot of people do not know as to what is happening as far as exploration in ocean is concerned. What is the actual work which is being done in the ocean science?
Ocean, as far as ocean is concerned, we have been doing last 35 years, we have been doing a lot of good work. One is ocean services. Ocean service means, for example, fishermen going out to the sea, and so we need to provide them where they have to go and catch more fish. It's got potential fishing zone advisories that we give, and that is very much benefited for them. And second thing is disaster. For some, when they go out, they may meet some weather storm or any high waves, etc. So we need to really give. It's called ocean state forecast. Right. So we provide the ocean state, and not only the fishermen going from land, but ships may be plying. There will be a lot of small boats may be going. So for them, we need to really give the warnings, etc. It's called ocean state forecast. It's called ocean services.
Okay.
And second thing is ocean survey. We need to really explore oceans around us, and to see whether we can really derive energy, we can derive minerals, etc.
But I think fairly, as far as the ocean survey is concerned, is it something which is very new for the ministry as well?
Ocean survey is very new, and we have been silently doing this ocean survey. And for example, we have a term called exclusively economic zone, EEZ. There's a 200 nautical miles from our land, so the boundary of land. And that area belongs to our country.
Okay.
And whatever it is there inside, it belongs to our country. And so we need to really know what is really there. So the so-called is called EEZ survey. So we have almost completed EEZ survey.
Okay.
So almost complete, maybe about 10% is remaining. That we will complete another few months. So that will be a huge achievement which we have made.
And the findings of the survey, how do you really share it in the public domain?
At present, it is not available in public domain.
Okay.
And because EEZ data, especially the subsurface data, it cannot be shared with public.
Okay.
So it's only the top of the whatever parameter you may share, you can share.
Okay.
Because it leads to security issues.
Right.
So we will not. We have to take permission to share.
Okay.
That's number one. Number two is we have around us we have a lot of minerals. So we have an organization called, it's a UN organization called International Seabed Authority.
Okay.
They give permissions or contracts to different countries to explore some areas for getting minerals out.
Okay.
And so we have a contract. We are almost 20 years back we got a mineral contract for exploring minerals and over Central Indian Ocean. There are a lot of, it's called polymetallic nodules.
Okay.
And if you really, so we have explored that area now. So about 75,000 square kilometer is given to us. So for going there and also to go to peep into the 6,000 kilometer down we need a lot of technology. So we have developed the technology. We also taken polymetric nodules out, and we know how to process it. We have a lab in CSIR lab in Bhubaneswar. They helped us to process it. So we have everything. Unfortunately, we don't have a kind of permissions or laws to exploit it. I'm making operational mining.
Right.
So we have only explored it. So we know how much minerals are available and how much it will cost us if we really exploit everything. And so that kind of work, very tremendous work which we have done. Many countries have not done. So only very few countries, very advanced countries like UK, France, Germany, those only very few countries, of course including China, they have done some exploration work. So that kind of exploration, but we have been doing it very silently, that work. So now once UN comes out with a rule saying that now countries can start exploiting it, we are ready.
Okay.
We have technology, it's called deep sea mining system we call. Somebody has to go down with the ship, some instrument has to go, take it out and bring back to the ship and process it and bring back to the labs like in Bhubaneswar and process. And what we will get is metals like copper, nickel, cobalt, manganese. It is huge money it involves.
So India does have a lot of mineral potential, and the Ocean Survey ensures that whatever is there, we have it on the paper ready. So you were saying that UN is going to devise some laws after which it will be left to the countries how they take it forward.
Yes.
So do the individual countries also need to come out with certain laws when it comes to mineral exploration?
Yes, we have our own laws, and so we have to whatever we do it should be within our existing laws.
Okay.
And so at present our laws permit that we can go out and explore the minerals in the deep ocean. We have been doing it.
But Mr. Rajeevan, what are the biggest challenges which you see as far as the ocean science is concerned? Which are the gap areas where the country needs to work on, or where the institutes need to work on, maybe in terms of technology? How do you really see that?
Yeah, see, ocean science is very expensive science. It's you need a huge money. You need ships. We have 7 ships. We have ministry have 7 big ships, and we use that ships to maintain the ship itself is very costly. Even if now the COVID has come, the ships we are not able to go there with the ship outside. The ships are anchored at different places. Even anchoring, we spend 100 crore.
My God.
Okay,
that's
so
a huge sum.
huge sum. So even to keep it in a garage, you need money. Okay, so it's a huge sum.
But why do you say that you need so much of money even when you have to anchor the ship?
Because the engine cannot be stopped. You need crew people. We are given the contract with the Shipping Corporation of India. Those people should be there in the ship. You cannot leave ship as it is. So an engine has to be on.
Basically on the maintenance
side.
Right.
And if then you can think of going with the people 30 days, 40 days out. How much money is required? It's a huge investment you need.
Right.
But we have been doing extremely well. But what we need is, also we have put a lot of observation network in ocean. Like over land, we are putting observation network. We have observations over oceans also.
Okay.
It's called ocean data buoys. We have Argo floats. These are all highly sophisticated instruments. Even to buy one instrument is very costly, and to maintain it again, it is very costly. So investment in ocean is very huge.
Right.
So, but a country like India should invest more and more.
Right.
And the second important problem is what we have is the technology.
Right.
We cannot go to a shop and buy a technology. It's not available. Atmospheric science, for example, weather, for example, automatic weather station. We can go to a shop and buy. It's readily available. Ocean technology, it's not available because like 40 years, 50 years back, like space technology, people are not sharing the knowledge. Same way it's ocean technology. Nobody will share you.
So you're saying that other countries are also reluctant on sharing the knowledge
about sharing of technology, knowledge with any other country. So we have to learn ourselves, make mistakes, and develop ourselves.
But before we go to another break, my one last question to you before the break is that you obviously need a very specialized manpower for doing this.
Yes.
How about the scientists? How about the technological manpower which is involved? How do you really train them? What kind of specialization do they really know? Because I'm sure the lakhs and lakhs of people who are going to watch this program, the students would be wondering how to get into this niche area.
Yeah, so for doing ocean science, for example, giving forecasts, etc., we need people with physics, maths, and oceanography background. Okay. For doing technology development, we need people with engineering background, basically mechanical, electrical, communication. So it may not be communication, but electrical and mechanical kind of people we need. And we have an institute in Chennai. It's called National Institute of Ocean Technology. It's last 25 years we have been working. and they have about 150 good scientists, engineers, and they have been doing a lot of good work. And we will be happy to invite more people to the institute, and also they can also participate in our cruises which we normally do.
I'm sure when the students watch this program, and the upcoming and the budding engineers who want to specialize in the field of ocean science, I'm sure they would be delighted to hear what you've said.
It's a very challenging job.
Right, it's a challenging job, but the government of India is investing really on this niche area, but many more milestones to be covered. But let's take a break at this point of time. When we return, we talk about seismology and the science of earthquakes. Have you really understood that well? Back in a moment.
India Science is an internet-based science TV channel initiated by the Department of Science and Technology, Government of India, implemented and managed by Vigyan Prasar. India Science on the URL www.indiascience.in is a bilingual channel with content in Hindi and English. It can be accessed on any internet-enabled device. This video platform is dedicated to science and technology knowledge dissemination with a strong commitment to spreading scientific awareness, especially with Indian perspectives, ethos and cultural context. The India Science mobile app can be downloaded from the Google Play Store and Apple Store.
Welcome back after the break. We are in conversation with Madhavan Nair Rajeevan, who is the Secretary to the Ministry of Earth Sciences. He is also the Chairman of ESSO and also the Chairman of the Earth Commission. Talking to you, sir, about seismology, and a lot of work is being done in polar science as well. We'd like to understand the milestones which have been achieved in this particular aspect.
As far as seismology is concerned, as you know that our country, especially northern part close to Himalayas, is a very earthquake prone area. We divided the country into 5 zones, zone 1, 2, 3, 4, so 2, 3, 4, 5, Delhi comes on zone 4. And so at present we don't have good science or technology to predict an earthquake. We cannot really predict when it will, next earthquake will happen. But we have now good technology to say when earthquake happen, we can immediately tell the people and earthquake has really happened. And of course, we have, a lot of research is going on to get some kind of precursors before earthquake happens. So a lot of research, not only in India, worldwide research is going on. Probably one fine morning we may be able to do it, but at least for next few years will not happen.
But why do you think, Mr. Rajeevan, is so difficult to predict an earthquake? We do not have those kind of specialized equipments?
Not question of equipment. We are not able to get a good precursors. So we some indication should be there that this if this happens, then it will be followed by an earthquake. Earthquake happens. It's a basically energy development. Energy build up, and one fine morning the energy will be released. So when it will be released, we don't know. Energy, we know, we can measure how the energy is getting built up under the earth, and we don't know, but when this energy will be released. When the energy is released, only the earthquake happens.
So a lot of work is being done as far as the seismological studies are concerned, but what about polar science? How is India really making a difference at the global level as far as polar science is concerned?
Polar region is also very important for, not only for India, for the whole global climate. We have 3 poles, Arctic, Antarctic and Himalayas we call the third pole. Himalaya is very important for all of us because it contains ice, snow and glaciers, so Himalaya also becomes very important. And as far as India is concerned, for polar science, India is a leading country. For example, in Antarctica, we started going Antarctica in 1980s, early 80s. We first built a research station, Dashna Gangotri. And so we are the first few countries who have gone there, and we are a part of Antarctica Treaty now. India is a part of Antarctica Treaty, who signed the Antarctica Treaty. So from early 1980s we have been going there. Now the Dashna Gangotri has gone under the snow, so the station has disappeared. We have now 2 more stations called Maitri and Bharati. Maitri also become very old, almost 30 years now. and Bharat is a very new one. So we have 2 stations, and we send about 100 to 120 people every year.
Okay.
So they go there, take observations, and so Antarctica is very important. We have been doing a lot of good work, and we also now ventured into Arctic. Arctic is a very new grey area, and 2008 we established a new station there. It's called Himadri, and it's a place it's called Svalbard in Norway. So they given us small land and a small building. So we have set up an observatory there. So there we go only during summer period, our summer period. Winter we cannot go there. So that observations are also we have been doing, and we do a lot of good work in Arctic research.
Okay.
And also we have set up a new station in Himalayas. We have gone up to 4.5 kilometer. I remember that I have gone in a helicopter there, gone for inauguration, etc. So people go there, and the station is called Himansh, and so the purpose of that Himansh observatory is to find out the glacier melting.
Okay.
What is the dynamics of glaciers? We know that people are...
And to what extent it is happening.
What is the physics behind it, dynamics behind it. And so people are telling about Himalayan glaciers are melting, and one fine morning all water will come out and all. so we want to know really what is really happening. So that MoES is doing a lot of good work in polar science, especially Arctic and Himalayas and Antarctic.
So what is the next milestone if you look at the entire ministry in totality? How would you really briefly summarize the kind of achievement which you have really gained at the ministry level? Yeah.
Before that, I would like to add 2 more good areas where we have been working. One is on coastal research.
Okay.
Indian coasts are very important. It's also vulnerable to storms and sea erosion, etc., and sea level rise, etc. So we have a center in Chennai, National Center for Coastal Research. They have been doing a lot of good work, and especially studying on how the sea levels are really eroding the sea coast. And also they have been doing a lot of work on beach restoration. We have done recently beach restoration of Puducherry.
And that's fairly a new area.
A new area. Beach restoration. Puducherry. The one fine morning the beaches disappeared. So they told us what it happened and how we can restore it. So we have done a good work, and now the beaches come back. We have spent about 25 crore. We have developed some kind of technology, put it on the sea, and that will allow not too big waves to come, and it will break. So the beach has come back. So beach restoration kind of work, that also we are doing it. And we have another small center in Kochi. It's called Center for Marine Living Resources.
Okay.
So we go out in the ship. We have a special ship, Sagar Sambada. With the ship we go there and explore the living resources like different kinds of fishes, etc. So the inventory, basically inventory of living resources we are making. There also we are doing reasonably good job.
And all good work is done so silently that not many people know.
Yeah.
And which is where I think Vigyan Prasar is making a difference.
Yeah, that's good.
But this Independence Day special, what is your message, Mr. Rajeevan, to all the people who are going to watch this program? And you've really given us a minefield of information today. But what is your message to the people this Independence Day?
Message is that, our Earth system science can do many things for the society. And we have been doing it very silently, and we have to commit for more and more work, research work, as well as application for the society. We have to save people, we have to find resources for the people, for some bringing wealth, etc. We have to help people like farmers, fishermen, etc. So we have our ministry has a lot of potential to help people. So which we are committed, so we will do more, and I am very sure with the support from the Government of India, with more funding and support of human resources, we will be delivering more and more products for a common person.
I'm sure you will come out with many more gems, and as you just said, that science does have an impact on the lives of the common man, and that's the goal, how to make the lives better with each passing day. So that's it on this special conversation with Madhavan Nair Rajeevan. It was a pleasure talking to you, sir, and wish you all viewers a very happy Independence Day.